Okay, for topic 4, we're going to look at graphing equations in slope-intercept form. Okay, so the steps to graph an equation in slope-intercept form is first, you need to solve for y if the equation has not already been given to you in slope-intercept form. So remember, slope-intercept form is the form that looks like y equals mx plus b. So in order to use this form, solve your equation for y if it hasn't already been. Okay? Then you want to determine the slope and the y-intercept. And remember, the slope is the coefficient of x as long as you have solved for y, and the y-intercept is the constant, again, as long as you've solved for y. Once you have figured out the slope and the y-intercept, you have to plot a point you know is on the line, and that's the y-intercept. We know what the y-intercept is, so we plot that, and then we apply the slope to figure out which direction our line is going. And then you connect the points of the line, and you're done. So for example 5, it says graph each equation using the slope and the y-intercept, okay? So for part A, we have y equals negative 1/2 x plus 5. So this has already been solved for y for us. We just need to figure out the slope and the y-intercept. So my slope is negative 1/2, and my y-intercept is 5. Now, for this to be a y-intercept, it would have to be the ordered pair 0, 5, so you can also think of it like that, okay? Now, when it comes to the slope, you can always apply your slope in two directions, okay? Now, when you have a negative slope like we do here, put the negative very clearly in one spot or the other. So I'm going to put my slope, I'm going to put my negative in the numerator of my slope. So this is going to tell me to go down and to the right. And then once we start graphing, I'll show you the other way you can apply your slope. So you always start with the point you know is on the line, which is the point 0, 5. So at the origin, I don't go left or right, but I go up 5. So up 1, 2, 3, 4, 5. And then from there, we apply our slope. And our slope is negative 1/2. So we're going to go down 2 and then, or we're going to go down 1 and then to the right 2. So down 1, to the right 2, down 1, to the right 2. Now, if you have a slope that is negative, okay, so negative 1/2. Well, we can treat that negative two ways. We can say this is negative 1 divided by 2, or we can say this is 1 divided by negative 2, okay? Well, if you put the negative in the numerator, you go down and to the right. If you put the negative in the denominator, you go up and to the left. So from the original point, the y-intercept, I could go up 1 and then I'd have to go to the left 2. But you can see I'm still on the line. I could go up 1 to the left 2, still on the line. So you can always apply your slope in two directions. So if you're ever given a Cartesian plane like this and you run out of room, just try applying the slope in the other direction, okay? So we now just connect the points with a line, and please don't forget your arrows. Serious pet peeve of mine when people forget the arrows, because the solution, this line goes forever, and those arrows indicate to the reader that, hey, we know this line goes forever. Okay, for part B, we have 3x minus 5y equals 10. So in this case, we do want to solve for y. So over here on the side, I'm going to solve for y. So we have 3x minus 5y is 10. I'm going to start by subtracting 3x from each side. So on the left, 3x minus 3x is just 0. So that leaves me with negative 5y. And then on the right, I'm always going to put my x term first and my constant second. So I'm going to write the right-hand side as negative 3x plus 10. Okay? And then once you get it settled like that, you want to divide each term by the coefficient of y. So I'm going to divide each term by negative 5. So negative 5 divided by negative 5 is just 1, and then 1 times y is y. Negative 3 divided by negative 5, don't write that as a decimal. Leave it as a fraction. Just simplify your sign. So I'm going to think of this as 3/5 x. And then 10 divided by negative 5 is negative 2. So this right here that I've just put a box around is the exact same thing as what we started with. It's the same line as 3x minus 5y equals 10. It's just in a format that's easier for us to use, okay? So remember, once you solve for y, the coefficient of x is your slope. So this tells me to go up 3 and then to the right 5. And then my y-intercept is 0, negative 2. Okay? So we want to plot 0, negative 2 first. You always have to start with a point you know is on the line. So 0, negative 2 is right here. And then from there, I want to apply my slope. So remember, my slope is 3/5. That tells me to go up 3 to the right 5. So up 1, 2, 3, and then to the right 1, 2, 3, 4, 5. Okay? I could go up 1, 2, 3 again, and then to the right 1, 2, 3, 4, 5. but then I'm out of room. So if I wanted to graph another point or plot another point, I could go back to my y-intercept, and instead of going up 3, I could treat my slope like -3 over -5, like what we had right here to begin with. And if I did that, I would want to go down and then to the left. Okay, so I could go down 1, 2, 3, to the left, 1, 2, 3, 4, 5. And you can see I'm still on the line. And pretend I actually went through the points. So there you have it. Okay. So that is graphing when you have a point and a slope, or not graphing when you have a point and a slope, but using the ideas of graphing with a point and a slope by just taking your equation and solving for y. You get a point, the y-intercept, and then the slope for free. All right, let's look at example 6. So in example 6, it says graph each equation using slope and y-intercept. So these are going to be kind of special equations where something unusual happens, okay? So the directions again just say graph using slope and y-intercept. So our goal is going to be to at least try to solve for y if possible, okay? So I have 4x plus 5y equals 0. So I would want to try to subtract 4x from each side. Well, 4x minus 4x is just 0, and then 0 plus 5y, or 0 plus 5y, 0 plus 5y is 5y, and then 0 minus 4x is just minus 4x, okay? Well, I'm going to move this over just so I have plenty of room. I have 5y equals -4x. I would want to, at this point, divide both sides by y, or by the coefficient of y, which is 5. So 5 divided by 5 is 1. 1 times y is y. And then I get -4/5 x. Notice in this case, we're missing a constant. So what that means is technically, I'm going to put it down here just so you can see, technically we have y equals -4/5 x plus 0. Okay, we just don't write the plus 0. So that means this line goes through the origin. Okay, so when you go through the origin, you're just going to have an x term and a y term. You're not going to have a constant term. But that's no big deal. So we want to plot our slope and our y-intercept. So our slope in this case is -4/5. My y-intercept is just 0. So I'm going to plot the origin. And then I'm going to go down 1, 2, 3, 4, and to the right 1, 2, 3, 4, 5. I could also go up 1, 2, 3, 4, to the left 1, 2, 3, 4, 5. As you can see, these points are on a line, so we connect. And there you have it. So just be on the lookout for those equations that have an x term and a y term, but no constant term. Nothing to be afraid of. We just go through the origin. Okay? Now for part B, notice we're missing an x. And if we're missing an x, that means we cannot touch the x-axis. We can only touch the y-axis. So that tells me that this line is horizontal, because the only way to live in the Cartesian plane where I touch the y-axis and I don't touch the x-axis is if I'm parallel to the x-axis, which makes me horizontal. So in a situation like this, when you have just one variable, solve for whichever variable you have. So we're going to solve for y. So I want to start by adding 4 to both sides. Well, -4 plus 4 is just 0, so I'm left with 5y equals 10. And then I want to divide both sides by the coefficient of y, which is 5. Well, 5 divided by 5 is just 1, which leaves me 1y. And then 10 divided by 5 is 2. Is it positive? Yeah, so that's going to be 2. All right, so this tells me I'm a horizontal line and I go through the y-axis at +2. So I would look like this. Okay, and then finally for part C, we have 3x plus 6 equals -3. Notice there's no y, and without a y, I cannot touch the y-axis, but I have to go through the x-axis. So the only way for that to happen is if I'm parallel to the y-axis, which would make me vertical. So this is a vertical line. Now, because there's no y, we can't solve for y, but that's not a big deal. We could still solve for x. So let's go ahead and solve for x. So I want to start by subtracting 6 from each side. 6 minus 6 is 0, which leaves me with 3x equals -9. And then I want to divide both sides of the equation by the coefficient of x, which is 3. 3 divided by 3 is 1. 1 times x is x. And then -9 divided by 3 is -3. So this tells me I am a vertical line and I go through -3 on the x-axis. So 1, 2, 3. So I'm going to look like this. All right, so that is graphing with a slope and a y-intercept, unless, like with example 6, part C, you don't have a y-intercept, but you're just a vertical line, so you do have at least an x-intercept, okay? So there you have it. Be very mindful of the vertical and horizontal lines. They're not hard. Everything with vertical and horizontal is actually a bit easier. You just have to know the difference between them. And then, of course, be on the lookout for when you do not have a y-intercept other than the origin. All right.